Good day, everyone. Happy New Year and welcome. I'm Jack Van Horn from the University of Virginia, and I'm very proud to welcome you to this edition of our 2023-2024 Foundations of Biomedical Data Science Seminar Series. The lecture series is supported by UVA's Integrated Translational Health Institute of Virginia, the College of Arts and Sciences, the UVA School of Data Science, and through a grant from the National Institutes of General Medical Sciences. Since 2016, the Foundations of Biomedical Data Science Seminar Series has focused on the use of data science methodologies, artificial intelligence, deep learning, and statistical modeling as they pertain to differing themes in the biomedical and health sciences. Our theme for this year is focused on building partnerships for generative AI training in biomedical and clinical research, where every Friday we enjoy presentations from a wide range of leading thinkers about the issues, promise, and opportunities and hurdles associated with the emerging notion of AI-based methods applied to biomedical science data types. Indeed, we would like to welcome everyone and remind them that they are welcome to apply for our 2023-2024 application cycle. Junior faculty are strongly encouraged to who are working in areas such as development of generative AI methods applied to biomedical research, and those junior faculty actively utilizing AI in their biomedical teaching to consider applying. We find that this is a very exciting and engaging program which brings together AI platform developers and university level educators to better understand the power, promise, and potential perils associated with generative AI. Participants selected for our Biomedical Data Science Innovation Lab program will leverage these seminar presentations as vital material for our culminating in-person manuscript and grant project development workshop to be held at the Bahia Beachfront Resort located in sunny San Diego, California in June of 2024. Today, I am very excited to welcome our speaker, Rafael Alvarado from the University of Virginia. Dr. Alvarado is an associate professor and the academic general faculty in the School of Data Science at the University of Virginia, where he is the director of the Humanities Data Science Collaboratory. He earned his PhD in cultural anthropology and has been a career-long digital humanist. His research interests include textual analytics, the anthropology of AI, and the history of data science. In continuing our 2023-2024 Biomedical Data Science Innovation Lab and Seminar Series theme, Dr. Alvarado's lecture today is entitled Language, Knowledge, and LLMs in the Context of Biomedical Data Science Education. He will describe that all branches of scientific knowledge are duly constructed as formally ordered bodies of knowledge and informally shared understandings of the world and how things are done. Both of these forms are highly mediated through language and discourse, through the development of formal ontologies and vocabularies used to organize information through informal modes of speech that characterize communication between members of a knowledge community. The deployment of large language models in the context of biomedical science impacts both of these forms of language and knowledge, as well as their relationship to one another. Dr. Alvarado will talk about providing a framework for making sense of the changes that LLMs have had and are having and likely to have on biomedical knowledge. As always, we are streaming this lecture live and for recording via YouTube. If you're watching on YouTube, thank you so much for joining us. Also, our specially selected 2023-2024 Biomedical Data Science Innovation Lab participants, as well as alumni, are encouraged to submit any questions via the chat feature in their YouTube sessions. I will synthesize all of these questions and I will ask them on your behalf during the last 10 minutes or so of the lecture. And with that, welcome, Raf. I am very excited to hear your presentation, and we look forward to having a little chat at the end. Thank you.
Thank you for the kind introduction, Jack, and good morning or good afternoon, everyone, depending on which time zone you're on. I'm speaking from San Francisco this morning. So let me begin with the segue from what you just said about providing a framework. I'm going to begin with a quote that I've always liked. There is nothing so practical as a good theory. Kurt Lewin, and this is to stave off any of the empiricists in the audience who think that getting too philosophical about these things or too theoretical is of no practical value. In fact, I'm going to argue, and I'm going to try to demonstrate that reorienting our perception of what large language models are and sort of getting a sense of what they, quote unquote, really are may help us focus on a different research agenda than perhaps we're working on now, or perhaps to at least augment it. So let me begin with what I'm going to try to do here. First of all, most generally, I really want to focus on the effect of large language models on the biomedical field. I'm going to talk about the effect of large language models on knowledge in general, and then try to bring it down to biomedicine per se. and specifically how they might affect the transfer of knowledge. So it's both about how it affects knowledge itself and how it's transferred. And obviously this includes education, because education, although it's not limited to this, is clearly about the transfer of knowledge intergenerationally and otherwise. As a caveat, echoing the quote I just made, this is a preface that I'm providing. I don't actually have research, empirical research that would be grounded in what I'm going to describe. I'm going to give you a preface, or what in philosophy is called a prolegomenon, sort of setting up setting the table for a different kind of work. As I said, to reorient our understanding of large language models. And so consequently, it's preliminary and theoretical. And so I just ask your forgiveness getting into this on that matter. So the first thing is, let's describe a couple of items. Some of the basic concepts here. I assume a lot of you already know what large language models are and language models, but I'm going to describe it anyway, just in case you don't. So basically, a large language model is just the latest and greatest iteration of something that has existed for a long time. You can argue since the turn of the century with Markov. There are iterations of language models. And technically, a language model is just a statistical model that can be used to estimate the probabilities of word sequences. And these probabilities are often estimated from the data that you use to estimate the parameters of these models come from text collections. This is often described, and models are often described as models that predict the next word given a sequence of words. But I feel like it's better to just describe them as estimating probabilities for a variety of purposes, because they're used to do a couple of things. Broadly speaking, they can both interpret inputs and generate outputs of text as well. Just a side note, I don't know if you guys can see this because of my picture, but this XKCD comic here shows that the large language model employed by the woman on the right is not really doing a good job, because obviously the next word or the next letters in that sentence is not erudite, it is erupt. As a side note, I want to say that these large language models and language models in general are not just a side thing, or just a sort of niche kind of model within the space of machine learning or in data science. They're actually central to information theory. Claude Shannon, in his article, his well-known 1948 article on information theory, reintroduced the idea of a text model and actually showed text models as generative text models in order to frame his discussion of information theory. And so equally as general as information theory is, so are these language models in their applicability. They've been used for predictions of everything from nucleic and amino acids to words and pixels. We're going to focus on words because this is where large language models have shown lately. So if you look at a large language model, just in its most sort of basic structure, it looks something like this. You have a lot of input. I'm talking about a large language model and how it's used once it's trained. It's got a lot of input possibilities. You can give it search queries. You can give it sentences to be translated, questions to be answered, text to be summarized, any number of such things. And basically, these are all fed to a common model trained according to some function such as what you see at the top there. And that generates a search space within which you can produce the following kinds of outputs, depending on what you're inputting: search responses, translated sentences, and so on. This paradigm of what a language model is meant to do is true of language models and large language models. It's just that large language models do them so much more effectively. If we look at large language models, I like to think of the large language model as consisting of 4 broad layers. And it's interesting to note that each of these layers, each element essential to the construction of a large language model, such as ChatGPT or Bard, or actually the language models would be GPT and BERT. These models all require these big chunks of technology or infrastructure that only existed relatively recently. So the first is that they're built on top of massive text corpora drawn from decades of internet use. And so basically the web has been this huge aggregator of textual data, producing corpora of a magnitude unheard of before the rise of the web and the engagement of users in producing content on the web. And so that one interesting thing to notice that the condition of possibility for these large language models is the web itself. It's almost a byproduct of the web in some sense. The second part of a large language model that's interesting, what distinguishes it from regular language models, is that they introduce novel methods for representing textual data. And really there's a lot obviously that goes into the construction of a large language model, but I would point out that the single most important contribution was the development of word embeddings. And word embeddings alongside what are called positional embeddings that really provide, and we'll see this in a second, all of the information that a large language model is going to use to derive what it considers to be meaning. Without word embeddings, you don't have large language models as we understand them today. And large language models provide the bulk of the information that a large language model uses. The third part is that they're neural networks. They're not probabilistic models in the traditional sense. They're not other kinds of models. There are neural networks that have a huge number of weights, billions or in excess of 1 trillion weights sometimes, that are trained on predicting next words, as we've talked about, of not just words, but higher units of discourse as well. And again, because of the internet and the rise of massive infrastructural technologies that support the internet itself, such as what Google and Amazon have created, we've been able to stand up these very, very, very large models and train them, which takes months to do. And so we have the following, we'll look at a little more of these in a second, that we all know of: the BERT language model, the GPT language model, PaLM, Llama, and so forth. And finally, we have these products that really are catching our attention, which is the wrapping of a user interface and a set of tasks and some downstream training that makes these things act as agents within a context, and so that they can be brought into environments and domains such as biomedicine where they're useful. So all of those four things constitute what I would call the large language model. We oftentimes focus on I guess the second and third, sometimes on the first, but the whole thing I would say suggests it really constitutes what we're talking about. Now, here's a graphic taken from an article that shows, just to give you a sense of how many large language models have been developed since around 2019. And really, we're working within a 5-year window here where things start to get revolutionized. The big innovation in the transformer architecture on which these models are made took place in 2017. And soon thereafter, these large language models trained on the huge corpora that we described using these large neural networks were developed. And so we see there's been a lot of work, a lot of output here. We tend to focus on ChatGPT because it just happened to be the most successful among these, the most successfully productized large language model. And for a lot of reasons that historians of science would probably delve into, it sort of took center stage and has sort of captured the imagination of everyone. But there have been a lot, and there continue to be a lot of large language models in development. Now, the thing about them, putting them in the context of the general practice of text mining and natural language processing, it turns out that large language models, what makes them so interesting and so powerful is that they pretty much outperform all other language models and text mining algorithms on NLP and text mining tasks. So there are a lot of models out there, a lot of approaches to solving things like, how do we do named entity recognition? How do we do part of speech tagging, for example? One often uses a hidden Markov model for that. It turns out that all of those tasks are within the capability of these large language models, and they tend to do them very well. And so here are a list of these tasks broken down into what I call the natural language processing side, which is about language itself, and the information retrieval side, which is about working with collections of text. So I call these supermodels, a little bit of a pun there, but they really are super in the sense of uber or encompassing of all previous models. Now, within this field of biomedicine, there's been a lot of work developing these models or applying these models. There have been a lot of domain-specific models generated, and I here have a short list of those, some of the more well-known models that you'll see out there: Metatron, BioBERT, BioGPT, BiomedGPT, and so forth. I have these roughly distinguished here between those on the top, which are ones that are trained on research data and what I would call formal knowledge, as I described in the abstract. And then there's on the bottom, Gatortron and HiBERT and Clinical BERT are trained on what I might call informal data. Doesn't mean they're not rule-based or structured, because sometimes they're trained on things like reports, medical reports, and tests and so forth, as you can see in the second column. But there is a broad breakdown between models that are trained on research data and those that are trained on data that arises in the practice of medicine, which is an interesting breakdown. They tend to have a set of target tasks. One of the most common is the medical question and answer task. Another one interesting is medical relation extraction, which is like hypothesis mining, named entity recognition, messaging, document summarization, and so forth. And from this, a bunch of use cases emerge. I don't know if you can see in the upper right, but I have research, summarization, hypothesis mining. There's education question and answer. There's effective writing, using them to generate effective writing. There's automated grading that has been explored within this domain. And then there's stuff like, discharge summary writing, composing messages to patients, building virtual assistants in telemedicine, and so forth. So there's just been a lot of work in pretty much any place where language is used in the biomedical domain. You're going to find somebody trying to develop a large language model application for it. So, oops, let me go here. Oops, sorry, I'm getting ahead. So here's a distinction that's probably worth noting. We're not going to go into, though, but there are two general approaches to creating these large language models. One is to say, well, let's take an existing large language model, such as GPT, and use it as a foundation model and do some transfer learning or fine tuning and add specific content from a domain such as PubMed, and then create a model that way. And then there are others who are working vigorously to just from scratch, forget about building on top of a pre-existing model with language that's not directly relevant to the biomedical field, and just train directly on PubMed. And so you have those as well. I have a remark here in the right, which points out that there's been some interesting research that shows that generalist models without any training at all, without any extra inclusion of medical literature, for example, PubMed, can actually do really well and outperform some domain-specific models on medical questioning and answering. And so there's an article here, and if you guys want, if anyone wants references, I can provide those. But these folks from Microsoft have shown that that ChatGPT with prompting, and we're going to get into that a little bit later, can actually outperform these other models, which is really quite an interesting finding. Here's another distinction to look at here, is that these large language models, we want to focus a lot on how they're used in what the upper right there, the generative task of communicating with people and letting people interact with them through text. But they are also still being used for good old machine learning prediction tasks. So just something to keep in mind. We're focusing on the top one, but those other tasks are being performed as well by these. And there's a lot of work as well in using them for these things. And finally, I just want to give you another example, again, taken from an article, of how there are certain models that are both multimodal in the sense that they can be trained on image data as well as text data, and they can be used for a variety of tasks, such as the ones we just saw above, the generative one of interacting with people, but also doing a lot of classification and prediction as well. So they're, in this sense as well, they're supermodels. They're kind of all-purpose. They're kind of being positioned to do lots of different things. All right, so we've all heard a lot of hype about these. We've probably used them. We're probably, our jaws have dropped in certain contexts using them and so forth. But we've also read about some of the concerns. And so even though they've been proven effective at, passing medical exams, doing extremely well on medical exams, translating technical diagnoses to patients, summarizing research documents and so forth, they do have shortcomings in the area of knowledge and reasoning. And I cite three examples of these shortcomings. The first one is out of context learning. So large language models do really well when they're asked questions about stuff that is in the context of the corpus on which they were trained. But if you try to generalize out of that, they don't do so well. In fact, a lot of times when they work with out of context, or what we used to call out of sample data, they will produce hallucinations. They will just blithely just generate text that is completely false, both from a factual perspective, but also from an authoritative perspective. In other words, it might cite sources that don't exist, cite sources that look like articles, but aren't to be found anywhere in the world. And more recently, we've discovered that they have what have been called logical inference failures, something called the reversal curse. If you train a large language model on the proposition A is B, or if it successfully answers that question, it doesn't necessarily know the opposite, that B is A. And so all of these things and others as well, and this is all in addition to the bias questions and the privacy questions that are sort of go without saying, I think, at this point in time. There are accountability concerns for these models. Basically, if you read the literature, a recurring theme is that biomedical professionals and stakeholders basically want to know if these things can be trusted. And oftentimes the language is, can they be trusted like colleagues? I mean, can we just treat them like colleagues and submit them to the same sorts of expectations and punishments and rewards that we give to our colleagues about, getting things right and wrong? So how can we do this? Just a quick drill down on the reversal course. Here's an example. It can answer correctly who is Tom Cruise's mother and give the answer, Mary Lee Pfeiffer. But then if you ask who is Mary Lee Pfeiffer's son, it doesn't really give you an answer. This is an interesting question too, because the answer, who is Mary Lee Pfeiffer's son, there could be more than one answer to that. But even with that, it's just basically saying, I don't know. And we know that it actually has implicitly, in some kind of latent way, it actually kind of knows the answer, but it's not able to produce it. Okay. I want to make a quick aside on this, though. I think it's a little bit unfair to ask language models to do this, and we'll see in a second why. And that's because they don't possess an ontology. And what's often misunderstood about logic is that any logical problem, even the syllogisms from, the old scholastic syllogisms from the Middle Ages, they all require an ontology. They assume an ontology underneath. And these models do not have an ontology that connects the words in the model to connections. And so, for example, if you look at the right here, this is what you might need to have built into the model to make it be able to do things like that. It must have, at some level, some way in which it defines these inverse or reciprocal relations as mapped onto each other. And what we see on the right are the way that is expressed in a specific ontology language called OWL, using a syntax called RDF. But we're not going to go into this. This will come up a little bit later, but just a side note. So this question of trust then, how can we build trust in large language models? What will it take to treat them as colleagues, as been expressed very often in the criticism of these models in the biomedical field? There's a term that's out there to capture this expectation, which is an interesting reversal of the usual word of human in the loop, is that we want AI in the loop, which to my mind repeats an old mantra of having technology on tap, but not on top. How can we actually, sort of, maybe the word is domesticate these so that they can be incorporated into our working environment the way that we incorporate our professional colleagues? And so our current approaches to doing this are a couple. We have, alignment via reinforcement learning from human feedback, RLHF. We have the expectation or sort of the desire to make these models explainable, and there are a lot of tools to help do that. There's some interesting work on treating explainability as dialogue. In other words, not just like opening up the hood of a neural network and sort of seeing what it's basically looking at when it makes a decision, but actually getting these neural networks to explain themselves. Like if you ask it, why did you do that? It could give you the answer. But I'm going to argue that a lot of these approaches, solutions to this problem are based on hidden assumptions. I would call them even folk models about large language models and AI in general, which I think deserves some scrutiny. So, we should ask ourselves, are the contents of a black box enough to make such tools or machines accountable? And more generally, our whole framing of this ethical question or this practical question is to treat them as agents, treat them as professionals. Are they really analogous to agents? They are agents in the narrow sense of that term, but are they really analogous to people as agents as we normally think of them? And this idea of AI in the loop, what are we talking about when we're talking about this loop? What does that loop actually look like? And is that loop restructured by these large language models in ways that we can't really see? There are a number of questions here, but basically I'm just sort of setting up this idea that we can problematize the approaches that we have and take a kind of critical perspective at what assumptions they're making about knowledge. So to build trust, I'm going to argue is that we need to understand large language models' relation to knowledge. We assume they possess knowledge and intelligence, but historians of science have shown that we've always overestimated the capabilities and qualities of interactive machinery. From the beginning, we've attributed intentionality to them, and not just lay people, but developers as well. And it's interestingly the case, as Lucy Suchman argues, that the opacity of these systems actually encourage us to do this. And so what we really want to do is focus on something that philosophers call justification. So if we want to say that large language models possess knowledge, we want to make sure that they possess justified true belief. Okay. And this is a traditional sort of, I will say, undergraduate understanding of what knowledge. If you get, into philosophy itself, there's some very sophisticated rebuttals or developments of this idea, but we'll stick to this. This is good. It's justified true belief. And the reason we say knowledge is more than just true belief is that sometimes people can be correct by accident, right? You can predict the outcome of a game or the weather, and be correct, but it doesn't mean you knew about the weather or the game. You just kind of got lucky. In some cases, it doesn't matter if you survive based on that decision, but we want more than that, right? Good luck is not a good long-term strategy. So let's look at this in a little bit more detail. Typically, justification normally entails understanding the process by which a claim is made. In math, we have proofs. In science, we have reproducibility. In law, we have, I guess I'll call it logical validity relative to code of law and precedent. In religion, we have appeal to interpretive authority relative to sacred texts and traditions. In almost any domain in which knowledge of some kind is promoted, distributed, consumed, there are canons of justification. And so given the opacity of LLMs, what can we provide for justification of their claims? So one common approach, and I think this is sort of the assumed approach of most people who develop them and who have sort of, taken the red pill, if you will, of machine learning and not worried about whether you understand the model, is just pragmatism. If something works, it's true. But I'm going to argue that this is unsatisfying because in order to arrive at an understanding of knowledge that gives us trust, we need to know why and how something works. And, as we mentioned earlier, we want LLMs to be able to explain themselves to us and not just say, look, it worked, don't worry about it. So the approach then I'm going to take is this, and just two general questions. One is, what is the relationship between large language models and language? And the second is, what is the relationship between language and knowledge? And from there, we can make an assessment of how large language models are related to knowledge and then proceed and interact with them in a more accurate way. So I'm going to begin with this quote here for this section that I think is funny but true. Every time I fire a linguist, the performance of the speech recognizer goes up. This is attributed to an IBM scientist or engineer, I'm not quite sure, Frederick Jelinek. This is one of these quotes that has a lot of different attributions of context. But it's used a lot, and it captures an interesting fact about the history of language model development, is that the language models that we have today were not built on any linguist's understanding of language, at least at the time, right? Because at the time, during the 70s, say, when these things are being developed in 80s, Chomsky and linguistics held the day, and this older kind of linguistics, more statistical based, associated with, say, Zelig-Harris, was out of favor. And so these models are developed, interestingly, by a much older understanding of how language should be studied. And that particular theory of language is captured under the concept of the distributional hypothesis. And basically, the distributional hypothesis says that the meaning of a word can be inferred from its context. Okay, Raymond, I should say Firth, not first. Raymond Firth put it this way, that you shall know a word by the company it keeps. And Ludwig Wittgenstein, the great philosopher in the early 20th century, basically had the same idea by saying, look, when we want to understand the meanings of words, we don't want to necessarily look at how their connection to the world. We simply need to know what the meaning of a word is in its use. And so this idea of meaning has been operationalized by the distributional hypothesis, has been operationalized in the concept of word embeddings. So word embeddings basically capture the statistical distributions properties of words in their context. And that provides all of the meaning that LLMs use to generate the outputs that it generates. These LLMs actually refine these embeddings during training, making them more context specific and more powerful. But basically, it's still working on word embeddings, and word embeddings are just operationalizations of the distributional hypothesis. The important thing to note here is that at no point are these models working with the referential function of language. They're never, ever connecting words to things in the world. It's hard to even imagine how they could do that, or to implicit ontologies, as I mentioned earlier. It's purely a horizontal, if you will, statistical operation of capturing which words go together with which other words. So this is a quick graphic to show you how the data are generated, at least just the word embeddings, which are used to map onto sentences, which are then fed into language models. If you take this sentence, the quick brown fox jumped over the lazy dogs, the way that we would gather the meaning of the terms in a corpus full of sentences like this is to take each word in a given sentence and associate it with its context, defined as the previous two words and the following two words. And that's a hyperparameter that you can vary. And you can see that the text on the left can be converted into text on the right. You can see that each word is associated with 4 other words. And so you have like a little mini bag of words, if you will. And then that gets compressed or understood statistically and is used to train a neural network that produces these weights. And so every single word then in a vocabulary associated with the corpus will then have a number of weights associated with a number of features that the neural network produced as a result of training. And so just to reinforce the point that that's all that we're doing to understand the meaning of words. We're not doing anything else. We're not connecting them to ontologies. We're not connecting them to things in the world. And so it's an interesting question at this point that, are large language models, of course they are language models, but say from an outside perspective, from a linguist's perspective, are they language models? I would argue in a certain sense they're not, because they do not operationalize grammar-based theories of language. And a lot of linguists think that's what language is. If you ask Noam Chomsky or Steven Pinker, they're going to tell you that's what language is. Language is essentially grammar. And the discursive dimension of language is an epiphenomenal aspect of it. I would also argue that they're not language models in the sense of models, statistical models, because they're inseparable from their data. And it's a criterion, for ideally a model should be completely separable from its data. Data should be used to estimate parameters, and then you should be able to throw the data away. And you can't do that with large language models. They are intrinsically bound up with the data that are used to train them. So this leads us to the question of, well, how they relate to knowledge. If a large language model is trained on this particular conception of meaning, and this conception of meaning has nothing to do with reference, then what does that mean for knowledge? So I'm going to quote Richard Feynman here, who's not a philosopher of science, but who's a great scientist, about some really basic distinction that he's been known to make, which I think makes a lot of sense. And here it's captured in this idea about a bird. You can know the name of a bird in all languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird. So let's look at the bird and what it's doing. That's what counts. I learned very early the difference between knowing the name of something and knowing something. So that's an important distinction there between knowing the name of something and knowing something. Knowing something requires actually engaging with the thing itself that's referred to. And of course, LLMs don't do that. So if the authentic knowledge requires application of the referential function of language, then LLMs do not possess knowledge in this sense. They know the names of things, but not things in themselves. So if we think of experience and experiment as essential conditions for epistemic justification in biomedicine, then LLM sentences, they don't justify the condition of justified true belief. So we might want to say they don't know anything, but this is unsatisfying, right? So what are they actually then? Where do they derive their power from? Well, I'm going to argue that they are not language models per se, and I know this is a little bit of a rhetorical provocation because you can always say, yes, they are in a very narrow technical sense. I call them discourse models. They're discourse engines because they model discourse, and I'll explain what that means in a second. They predict and generate sentences without the intermediary of a grammar. They are generative concordances. I would call them generative recombinant concordances of text corpora on which they are trained. And so the thing I'd like to emphasize is that they possess knowledge to the extent that knowledge is linguistically constituted. And this is an important concept we're going to look at in a second. So it follows that they're best studied through the lens of fields that focus on discourse. So this is the great shifting of attention I'd like to make here, is to shift our attention from language in the sense that you might have learned in college, in studying Chomsky or whatever, onto language as discourse, which is more how anthropologists have studied language over the last few decades. And so the idea then, back to trust, if LLMs are discourse engines, i.e. not based on rules, ontologies, or experience, then how can we assess their effects on knowledge and education? And basically, I'm just arguing that in order to trust them, we have to understand what they know and how they know. And the best way to look at this is through the relationship between discourse and knowledge, which we'll look at in a second. Well, actually, right now. So getting back to Zelig Harris here, who created the distributional hypothesis, the first sort of scientific formulation of it. In his book, Discourse Analysis, we may not know just what a text is saying, but we can discover how it is saying it. What are the patterns of recurrence of its chief morphemes? So just reiterating the distributional hypothesis and noting that it is closely associated with the concept of discourse. And then you have the philosopher Paul Ricoeur, who says that the linguistics of discourse has different rules than the linguistics of language. So what are those different rules? So the basic distinction I want to make here, just want to bring to your attention, which is fundamental to the study of language. It goes back to the early 20th century when Ferdinand Saussure, who's in the first column, makes a distinction between langue and parole. He's French, and so that's language and speech. Chomsky describes these as the difference between competence and performance. I call them the difference between grammar and discourse. And large language models, as we've just seen, focus on level 2, and they do not make any reference to level 1 at all. We may think that they are learning those in the weights of these massive neural networks, but it's hard to call a trillion parameter entity a grammar. That would be crazy if you handed someone a grammar of a language and it had a trillion pages, as it were. So large language models operate at the level of discourse, not grammar. And when we talk about discourse, what are we talking about? Here is a model of discourse that is fundamental to its study. It basically points out that all discourse is composed of sentences. That's the elementary unit of discourse. And every sentence is ideally a speech act or utterance that occurs in a situation. And that situation has the elements of someone who's speaking, someone who's listening, a common situation that they share. It could be a clinic. It could be a lab. And then there's the instance, meaning it happened at a particular place and time. This is what we mean by discourse. We can actually organize the study of text mining and natural language processing, the particular activities within these fields according to these categories defined by this understanding of discourse. But what I want to do here in the limited time that I have going forward is just to point out that if you look at language this way as discourse, and you look at the elementary structure of discourse, what emerges is that it's always social. Discourse is always embedded in social relations because there's always a speaker and a listener, and the speaker and listener have a relationship to each other. It could be a power relationship. It could be a working relationship. It could be a kinship relationship. And the field that has been devoted with these adjacent fields below to the study of language and discourse is sociolinguistics, which studies the relationship between language and society and culture. And I'll point out these other fields as well: discourse analysis, ethnomethodology, anthropology of language, and the ethnography of speaking. So here are some findings from this field. Discourse encodes social relations. Anytime two people speak, the actual grammar of their sentences, the actual diction of those sentences will indexically reflect the relationship that they have. Sometimes this is explicitly developed, say, in the case of the military, and sometimes it's implicit in the kind of language relationships we develop with people. Discourse is always situated in a place and time. It has a situation. It implies a shared world or an ontology, as we saw earlier. Discourse also always occurs within a discourse community. Discourse comes in discourse genres. In other words, there are different kinds of discourse depending on the relationship between people. You can broadly distinguish between informal and informal modes of discourse. And finally, discourse operates within a network of communication. So you can think of discourse, if you think of a graph, and a common sort of, image that you get from social network analysis of different nodes communicating with each other, at each one of those edges is discourse, and those discourse, those conversations that are being had are going to be had in a certain way. They're going to have certain qualities by virtue of the nature of the relationship by which that they mediate. So, quick point here. This is a really important point. It's got a lot of depth to it, but I'm just going to quickly go over it, glide over it just to get to the next point, which is that when you look at discourse, language as discourse engines, we see immediately that they don't possess these traits. They actually don't understand anything about the shared situation between speaker and listener. They don't have a shared world. We just saw that they don't have an ontology and so forth. What do they have, though, is something that is in common with writing. So the thing about what we're looking at, the kind of data on which these models are trained, is that it's all based on written text, right? This is obvious. But what we have to understand is that writing is a form of discourse that detaches language from its context of use, and therefore it transforms all of the dimensions of the elementary structure of discourse that we looked at, and produces these really interesting transformations that make texts what they are. In other words, it gives them the power that they have to convey knowledge over time and space and so forth. And can't get into that too deeply here. It's basically the basis of the field called hermeneutics. But the idea is that we have, with our written discourse on which large language models are based, we have a kind of discourse which I'll call non-referential discourse. So non-referential discourse is the discourse, spoken language, say, captured in writing. Doesn't always have to begin with speech, but it's captured in writing. It's detached from a situation. And so what remains from that, sort of, if you will, the fossil remains of discourse in text is basically the linguistic forms that are used to have conversations. And I'm actually reading from the slide here. I'm kind of jumping ahead in the interest of time. What I want to say is that even though large language models do not possess specific utterances, used that are taken from a particular context, they do transmit and generate knowledge of a certain kind. And let me describe this here. So a large part of education is acquiring the vocabulary and the idioms of a domain language, independently of the facts of that field. So a large part of knowledge exists not in specific claims and facts, but in forms of language that make those claims possible. So following the work of Del Hymes, we can call this kind of knowledge communicative competence. So what I'm saying here is that what a large language model is capturing, and it's doing this based on, it inherits the same limitations that writing inherits from being separated from the context of its use. It takes that and then it decomposes that into a combinatorial logic of linguistic usage patterns that are common in those particular texts. What remains is a kind of ability to use language independently of its connection to the world. And that may not seem like knowledge. In fact, Richard Feynman likens that kind of, when people possess just communicative competence, like they can talk like scientists, we sometimes call that scientism. He refers to that in one of his famous speeches at Caltech, the graduating class at Caltech, as a cargo cult, where the outer form of science is learned, but the actual engagement with reality and understanding of how it works is not learned. But this is not actually, this is a little bit unfair because we do know that a large part of becoming educated is learning how to speak a certain way and learning the idioms and the vocabulary of a particular field. When you become educated in that particular field, a ton of it, like a huge percentage of what you're learning, isn't direct knowledge of the world, but all of the linguistic apparatus required to actually engage in a professional community to do that kind of research. And that's what large language models capture. And so what I would like to propose is that in order to understand large language models authentically, we ought to be looking at them through the lens of language socialization. And so language socialization is a concept that comes from anthropology. It was originally focused on looking at how language is learned by children in communities around the world. And the basic finding is that basically children become enculturated and socialized through language learning. In other words, when you learn a language, you're not just learning how to speak, you're learning how to be a person in a particular culture. You're learning a whole bunch of things about modes of behavior, about orientation of mind toward the world. And these things come in the form of heavily encoded, grammatically encoded language that you possess and that you then carry forward and that you employ in various contexts. And so this is what I want to argue is that, let me see if I can go here, that if we look at education as a particular kind of language socialization, learning the specific languages of a discipline, including both formal bodies of knowledge and informal ways of knowing, we can see that this is precisely what large language models are modeling. So just to repeat, they're not modeling, even though sometimes they look like they're doing it, a body of knowledge. What they're modeling are modes of speaking, ways of speaking that are associated with the practice of acquiring knowledge and using knowledge. And so let me jump ahead here because I just have a couple of minutes. We can see that language socialization in biomedicine takes place in different contexts. We have at least two contexts that we should pay attention to. One is the formal context of where you're being engaged with the research community, and there is informal context where you're, say, in the context of practice, where you're working with patients, doctor-doctor communication, doctor-patient communication, and we have language models associated with each of these. What I want to point out is that where this comes to a head, where you can really apply the concept of language socialization to large language models in the context of biomedicine is in the area of prompt engineering. And it's no accident that prompt engineering has emerged to be the most active area of development and training, if you will, in the use of large language models. It's in prompt engineering that you are engaged with the language model and understanding how it speaks, as it were, and getting and understanding how the language model speaks and understanding how to condition it on certain speech forms improves the productiveness and the effectiveness of those models, right? So it's precisely in becoming familiar with what we called earlier communicative competence, like how to speak for a certain kind of knowledge, that these models actually shine and become most productive. And so there's been a lot of work on large language models and prompting in the context of biomedicine. It's being touted as an essential form of knowledge that you should have in order to practice medicine going forward. And it's essentially a primary skill. And I've just got some, these are some examples of prompting strategies that I'm going to skip over here. What I want to do is stop at this slide and just simply point out that what is happening is that here on the left, you see a well-known sort of cheat sheet on how to prompt and interact with a medical GPT. This is one specific to the biomedical space. And to me, this looks a lot like Strunk and White or something like that. It's basically teaching you how to speak language. So the question I have is, although prompt engineering is ostensibly another means of training a language model, in another sense, prompt engineering is a way of training us to interact with the large language model. So we are being trained in a particular form of discourse in order to make these tools more effective in our particular context. And so the question that I have, the challenge that I have, and I'll conclude here, let me see if I can get this to change, is that given that, the kind of knowledge that large language models provide, which is communicative competence, even though they do in practice, effectively, they work as information retrieval devices as well, but really at the core, they're giving us communicative competence. And given that the role that large language play in the biomedical space as primary agents in both formal and informal knowledge transmission via prompt and response dialogues, prompt engineering, what kind of socialization is being played? So this is the research question that I would put before you. What are students learning when their acquisition of knowledge depends on their prompt engineering expertise? And what are the effects, intended and unintended, on the biomedical fields when every significant relationship is mediated by this process? And so I'm going to stop right there given time, and I do apologize for skipping over, some of the important elements of this argument. But in order to make the argument, it is necessary to go into some of these other fields, which I expect the audience probably doesn't have a lot of familiarity with, sociolinguistics, hermeneutics, and things like that. But I hope I have been able to convey the idea that proper study of large language models is through the study of discourse. And one of the most fruitful ways of looking at discourse, in particular looking at large language models to the extent that they're employed as chatbots and so forth, is through this concept of language socialization. And so I'll stop right there.
Thank you, Rep. That was fantastic. What a great overview of large language models and kind of how they're built and what they can do and don't do. It's kind of interesting because when the term model is used, and it's so much different than I think how a lot of people think of what one does when they're modeling. This is a probabilistic tree of, if you say this, the next most likely word is this, and you're traversing a tree, but it's not really a model like we would typically view a model. And anything that has weights with, a billion parameters is, you've got more parameters than perhaps you have words in your corpus. It's like having a map where, 1 inch equals
Exactly.
1 inch,
Yeah,
I'm curious about, do you ever see some degree of, I guess, compression or something where actual modeling does get applied to make it more compactified? But I'm not exactly sure if this question is accurate or not, but do you ever see where the modeling would actually play a role here?
Well, there is hope that, the word model is probably one of the most ambiguous words in science because every field uses it differently, and even within fields, it's used differently.
Yeah.
But let's just be very generous and ecumenical about that word. If you look at the transformer architecture, or let's say the encoder-decoder architecture, you look in the middle of it, there is, a codec. There is what's called a code, which is where you've taken all of the input and you've compressed it into some very reduced representation that is then used to produce its outputs. There is hope and belief that in that stuff, you're going to find something like what linguists hope a grammar, expect what a grammar would be. But I would argue that we're not going to end up getting transformational rules out of that, something like what Chomsky was looking for, or something like what other grammarians, folks looking at rule-based understandings of language. What we're going to see is some representation of a complex system that is both psychological and sociological. And I think it's going to reorient our understanding of language if we really take it seriously. My view is that grammars don't exist in the sense that we want them to exist. There is something grammar-like that's durably installed in the human brain that makes us able to speak. But a good part of what we think of as language as a totality also comes from interactive patterns socially, people monitoring each other, having grammars that are explicit and so forth, that are written down in books that monitor and construct our speech and so forth. So we're going to end up with a complex understanding of what that is. I don't know if that answers your question, but yeah, there is something in there in these models that in these large language models that are in another sense of model-like that we hope to be able to excavate But I'm thinking that when we actually get to that point, they're not going to look like what we were hoping for.
I liked the thing you touched on there towards the end of prompt engineering and how, maybe in the past, maybe like 2 years ago, when,
Right.
you'd open up your Google, uh, search bar and you'd say, show me, I don't know, NFL statistics, or I don't know, and you'd get out whatever the internet happened to provide for you. But with these chat GPT and other large language models, you actually need to craft those very specifically.
Mhm.
And that's a skill set that, you showed a number of books that people have developed on this, which I think is fascinating that, now we're going to have to learn a language in order to use these language, generative language systems like this. I find that fascinating. Can
That's
you say a
exactly
little bit
right.
more about that?
Yeah, I mean, that's where all the action is right now. It is in industry, folks trying to make business models out of this, work within biomedicine, within medical education, and even within the training of language models. One of the things that has been learned is that a lot of stuff that happens in reinforcement learning, the RLHF stuff, can actually be done at the very end with prompt engineering, or even as we saw from the Microsoft research I mentioned very briefly. You don't even need, because these models are trained on so much data, you don't even need to do domain-specific fine-tuning on these models in order to get them to pass medical exams. You just have to prompt them properly.
Yeah.
And so what that's doing is exploiting this property that these models have, is which they've captured all forms of linguistic interaction. So when you prompt a model, you introduce these indexical things that we would call in sociolinguistics, like formal and informal. Like, I want you to speak formally and as a scientist and to an audience that has these properties. You'll notice that in prompt engineering, what you're doing is you are itemizing all of the elements of the discourse situation that we described. At least that's a big part of it. And in addition, you're introducing things like task patterns, like I want you to give me a recipe, or I want you to go step by step chain of reasoning. But essentially, what you're doing when you're prompting is introducing all of these, what we would call sociolinguistic dimensions of language, in order to get it to focus on that area of the corpus that's relevant to you. So this, to me, reinforces the idea that what it's actually modeling are, these communicative competencies, and it's getting us to be more intentional about our understanding and use of these communicative competencies in interacting with the models. But the cost, I would argue, is that we may be training ourselves to think of knowledge in a certain way. And there may be some exclusions and inclusions, strengths and weaknesses that we should pay attention to when we walk into this new kind of language situation.
In our last minute or so that we have here, I want to get you to opine a little bit about how biomedical education could benefit from things like prompt engineering, or understanding a little bit more deeply about what these language models have embodied and what some of their strengths and weaknesses are, but how to use them as an effective tool for, I don't know, ingesting clinical notes and generating corpuses, and some of the other examples you gave in the beginning about chat bots with patients and that sort of thing. What are some things that people need to think about as we're building educational programs to train this next generation, where these large language models are just going to be ubiquitous?
Well, to me, this is a question that applies to education in general, and how they're being used. And I would defer to some really good research on this. I hate to just say Google this, that's not what I'm saying, but good articles about people specifically in medical education using medical question and answering paradigms and document summarization paradigms to work in the educational field. I'll just point out that right now there's an ongoing challenge in all educational spaces about the way in which we incorporate them into our education, and the best practice that seems to be emerging is to use this metaphor again, is kind of as a colleague, a kind of sparring partner to help you learn concepts, with the idea that at the end of the day, you should be able to, on your feet, be able to answer questions without the aid of a tool like this. So a lot of the question and response, setting, how people used to make index cards for themselves, flashcards. Think about that on steroids. That's one kind of example. There's an interesting one, prompt engineering pattern where you do role reversal, where instead of you asking questions of the chatbot, you ask it to ask you questions. You say, okay, I want you to reverse roles. I want you to ask me questions to answer a problem or to pursue a particular line of reasoning. And that has been shown to be, by those who are, interested in pursuing this, and maybe there's a little bias there, to be effective in medical education. I can provide, a syllabus or a kind of, curated list of what I think are the best articles on this. And there are a couple of them with there's some really salient examples, but that's one that comes to mind is this reversal role, and also thinking of it in terms of the broader field of education where we're all facing this problem.
Well, Ralph Alvarado from the University of Virginia, thank you so much for giving us this overview of large language models, again, what they can do, can't do, and kind of what they're representing. This was really fascinating, and I really appreciate you taking the time to kind of go through with this. Thank you to everyone who joined us. Once again, Happy New Year, and we'll see you again next week. Thanks, everyone. Have a great weekend. Thank you, Ralph.
Thank you, Jack.